Okay, yeah, so in this video, we're going to learn how to sketch a chain of absolute functions. So usually we're used to sketching a function which is at most one absolute function. And now we want to learn how to sketch a chain of absolute function in which you can be asked to sketch a graph in which there are two bits of absolute functions, and here we have 3 bits of them. So this is a kind of a tricky plot, but here we're going to go through it step by step on how to actually sketch a chain of absolute function. You see that? So the first thing that you do every time when you are given something like this and you are required to sketch, the first thing that you should do, which I'll write as step number 1, is to find the critical values. You see that? So now what are critical values under the context of a chain like this one? So critical values in this case, they refer to the values of x that one gets if you take each of these absolute brackets and equate them to 0. So the values of x for which each of these absolute brackets is equal to 0 is what we refer to as the critical values at this case. So which means the critical values are x equals to 1, x equals to -3/2, and x equal to 4. So these are the critical values that we have in this problem. So having these critical values that we have here, it allows us to create a distinct number of regions for which we can use then to solve or to sketch the curve. So if, for example, if you are to represent all these critical values in a number line like this, starting from the least to the greatest, so we have -3/2, and then let's say we have 1, and then we have 4, we see that having these critical values, it supplies us with 4 different regions that we can talk about. So we have this one, which I can refer to maybe as region 1, and this one which I can refer to as region 2, and this one which I can refer to as region 3, and this one which I can refer to as region 4. Now the question that we should ask ourselves is what is the importance of these regions? You see that? So these regions, this one, it is described as the region which takes everything which is less than or equal to -3/2, and this region is described as a region which takes everything from -3/2 but less than 1, and this one is described as a region which takes everything greater than 1 but less than 4, and this one is a region which takes everything which is greater than 4. So these regions that we have there, they are kind of special to us because if you are to sketch a chain, a chain of absolute function is as such. In each and every one of these regions that we have there, it is described by a particular function. So what we want to learn now is how to find that particular function which describes the original chain in that given region. So this is how we're going to learn how to go about that. You see that? So which gives us then the step 2 of our procedure in how to solve for this type of problem. So step number 2, it goes as follows. So now we determine the equation of each region above. You see that? So as we have stated now that in each of those regions that I have labeled as region 1, region 2, region 3, and region 4, this function that we want to sketch here, it is actually described by different functions in all those regions. So what we want to learn now is how to find all these functions that we're talking about here. So how can we determine all those functions? So to determine the function, we're going to go region by region, and then we're going to see how we determine all that. So for the first region, we'll consider this region now, x less than negative 3 over 2, like that. You see that? So x less than negative 3 over 2. So to find the equation that represents the function at this region, this is how we proceed. So at first we ask ourselves, when x is less than negative 3 over 2, what is the sign of all these three absolute functions? Remember, these absolute functions, they behave differently from region to region. So what we have to know now is what is the sign of each of these when x is less than negative 3 over 2. So in order for us to know the signs, we can just write these by definition. So by the definition of the absolute function, we know that the function x minus 1 is defined as follows. It is defined as the function x minus 1 every time when x is greater or equal to 1, and it is defined as negative x minus 1 when x is less than or equal to 1. This is how this function behaves. So every time when x is greater or equal to 1, the function is positive, but whenever x is less than or equal to 1, the function is negative, like that. Then the other function again that we have, which is the function 2x plus 3, it is as follows. So 2x plus 3 is also positive whenever x is greater or equal to 3 over 2. You see that? So negative 3 over 2, sorry. So for all values that are greater than that, this function will be positive. And then the same function now, it's negative every time when x takes values that are less than negative 3 over 2, like that. So which brings us to the last function, which is 4 minus x. So same thing, 4 minus x. It is defined as follows according to the definition. It is positive 4 minus x every time when that thing is greater than 0. So when x is less than or equal to 4, this function is always positive, but it becomes negative 4 minus x every time when x is greater or equal to 4, like that. So now we know how these functions are defined by making use of the definition. Now let's come back to this case. So now when x is less than negative 3 over 2, what is the sign of the first absolute function, which is this one? So if we check here, we can see that negative 3 over 2 is a number which is less than 1. So which means for this interval that is given, this first absolute function is going to be defined by the negative function. So it's going to be negative x negative 1. Then plus, now we move on to the second function, which is 2x plus 3. So we see 2x plus 3 that is given here. It is, what can I say? 2x plus 3 is negative when x is less than or negative 3 over 2. So this actually is what the same thing as that. So we see that this function is negative at this instant. So we'll have negative bracket 2x plus 3, like that. Then there is that negative which is there in the function. Then the next thing is 4x minus 1. So now what we see? So we see that every time when x is less than 4, this function is defined by positive, but it becomes negative when x is greater than 4. But negative 3 over 2 is less than 4, so therefore we expect that function to be described by that, which is 4 minus x. So the next thing, we just have to simplify this, which will give us negative x plus 1, negative 2x, negative 3, negative 4 plus x. So the x's cancel, this one cancel. So what remains is negative 2x. And then simplifying the remaining, we get negative 6. So which means for the region x less than negative 3 over 2, our function is described by this equation, which is a straight line. So we move on to the second region, which is x greater than negative 3 over 2 but less than 1. You see that? So now we x greater than 3 over 2 but less than 1. So what happens now in this region? So in this region now, what happens with the first absolute function? So we see now that every time when x is greater than negative 3 but less than 1, so for every x less than 1, this absolute is negative, so it's replaced by negative x minus 1. Then the next one, which is 2x plus 3, which is this one, every time when x is less than 1 and greater than negative 3 over 2, so we see that every time when x is greater than negative 3 over 2, this function is defined by the positive, so we get plus 2x plus 3 minus, then now again for this function we see that every time when we're less than 1, this function is positive. So every time when I'm less than 4, this function is positive, and here we see x is restricted to be always less than 1, so this function has to be described by that, which is 4 minus x. So simplify here to x plus 2x plus 3 minus 4 plus x. So these cancel, so we remain only with positive 2x, then 3 plus 1 is 4 minus 4. So the function is described simple by that. You see. So the next thing that we want to do is to consider the next region now. So the next region, as shown here, it's x greater than 4, greater than 1, less than 4. So we have x greater than 1, but less than or equal to 4. So what happens now? So we see that now, every time when we're less than 4, we're greater than 1. When x is greater than 1, this absolute function is defined by the positive part, which is x minus 1. Then the second one, 2x plus 3, as we see there, every time when x is greater than 1 and less than 4. So if you check here, greater than 1 lies here. So this function is also positive. So we get plus 2x plus 3, then minus, then 4 minus x in this region. So we see that we are still less than 4. So when we are less than 4, as we see there, this function is defined by 4 minus x, like that. So let's simplify, and what we get from here. So we'll get x minus 1 plus 2x plus 3 minus 4 plus x. So adding those, we get 4x, and then 3 minus 1 is 2, is negative 2. So the function is defined by this in that region. Then finally, we consider the final region now. So what is the final region? So the final region as shown here is x greater than 4. So what happens now when x is greater than 4? So when x is greater than 4, we see all these functions are the first two functions are positive. You see that? So every time when x is greater than 4, the first two functions are positive. So the first one is positive x minus 1. The second one is positive 2x plus 3. And for x greater than 4, the function, the other one is negative. So this will neutralize this negative, which is sitting there, and we get 4 minus x. So we simplify, we have x minus 1 plus 2x plus 3 plus 4 minus x. So these cancel off, and we get 2x. And then we have 3 minus 1, 2, so we get 6. So that's it. So now we have managed to get all the functions that describe our chain in each of these regions that we have there. So the only thing that is left for us is to sketch all these curves in their respective regions. So what we can do now is to create a Cartesian plane for which we are going to sketch all these. So we find our Cartesian plane like that. So we have 0, then we have y, then we have x. So now what I'm going to do, this is not allowed in exams for you to do this, but I'm just going to do it now for the sake of guidance to see how we actually draw this graph like this. So what we do most of the time, if you are to draw a chain, the first thing you show all the respective regions separately by using dotted lines which appear like asymptote. So we see that we have 4 regions. The first region is described by -3/2. The next is 1. Then the other one is 4. So we have something like this. So we have -3/2 somewhere here. Then we have 1 here, we have 4. So this allows us to get these sort of regions, which I'll draw as dotted lines. Note that they're asymptote, but they will serve as guidelines so that when I'm drawing my respective curves for each region, I do not protrude into the other region. So now how then do I go about sketching our main function? So to sketch our main function, I'm going to start drawing from left to right. So we see that for all values of x less than -3, our function is described by this equation, which is -2x minus 6. So it's a straight line with negative gradient, which is supposed to cross at -6 in the y-axis. And if you do your mathematics, you will see that also it has to cross at -3 in the x. So it's a function which is trying to behave like this. So it's coming from the left and it has a negative gradient. So a line with negative gradient will come something like that. And it's trying to cross at -3. So it goes all this way, crosses here, and it's blocked because it's not supposed to protrude onto the other region. So it's blocked. If it continued, it was going to come all the way up until it crossed at -6. But now it's not going to do that. Then now we're entering the zone -3/2 to 1. So what happens in that interval? So let's go and see. So when in the region -3/2 to 1, we see that our function is described by 2x. You see that? So it means it has a positive gradient and it crosses here in the origin, because we see that there is no. So if you do your mathematics, you will actually see that this function is going to continue exactly where this one ended. So it's going to go there, cross through the origin, go all the way up until it's blocked from protruding into the other region. So it's going to end there. So this one is the function y is equals to -2x minus 6, and this one is y is equals to 2x, like that. Then now we're entering the zone between 1 to 4. So how do we what is the function there? So in this zone, we see that the function is actually described by 4x minus 2. So this curve, it crosses at -2. The y-intercept is at -2. And if you do your mathematics, you see that it has to cross at half. So this function has to cross at half. So which means it's a very steep function because it has to cross here at half and go all the way like that. So it's going to be like that. And it's going to be blocked from going beyond that region like that. So it's just going to end there. So this gives us the function, which is y is equal to 4x minus 2, which was supposed to cross all the way here, but it's blocked. Then finally we have this function 2x plus 6, which we see that it's a function with a positive gradient, and it has to cross at x equals to 6, at y is equal to 6 somewhere here, and it has to cross at -3, which is also somewhere there. So if we were to draw it, you see that it has to be a very steep line again, something like that. Which was supposed to continue all the way up until it crossed at -3. But now, since it's bounded from going beyond that region, it just stops there. and we label it and say y is equals to 2x plus 6. So this is how you actually draw this chain of absolute function. So the graph that we're looking for is simple, this one that we're seeing above there. So that's how to sketch a chain of absolute functions. Mostly when this problem is posed, they don't go up to a situation where we have 3 absolute functions. They always consider a case where we just have at most 2, but it's good just to practice it at this level where you have many terms, so that at least you get effective in knowing how to plot this curve effectively. Otherwise, thanks for watching. So for those who have not subscribed, just hit on the subscribe button so that you don't miss solutions to